All right. Hello, everyone. Okay, so let me see if I'm live. Well, I'm hoping that I'm live. Anyways, so hello, everyone. In yesterday, we tried to understand a multi-agent framework. Um, what are different architecture styles and how we can use it. So let's quickly recap this, and then we'll try to implement that. Um, okay, so for now, let's just go through the notes that we have collected yesterday. So what we are looking at is multi-agent framework. So our use case was like if we send any query to our agent should redirect it to it agent should redirect it in between different agents, and those specialized agents will to perform some operations on that query, and it will generate an output. And when our all the loops of those subtasks is ready, then we'll give an output. Okay, so we've seen that yesterday. Now today we'll try to implement this, but let's quickly go through what are different orchestration styles or frameworks we have. So first one is like predefined hard coded logic. So this logic says like we have to maintain one YML file or Python script that decides where we want to redirect our query in between, right? So let's say query goes to a orchestrator will decide where that wants to pass it to different agent. Okay, so if developer sets asynchronous execution true, so that will uh, run those queries parallelly, and if it is false, obviously it will run sequentially. But this is like old way, and this is like a manual way, I guess, we can say, because we have to decide that through the YML, so it's hard coded only, although it is configurable, but it's not up to the LLM to decide like which agent should be best one to handle this type of queries, right? So we are not going with this approach for now. Second approach we have is dynamic LLM orchestration. So this is a React pattern where we it's a framework uses to control. There's a central manager or supervisor, you can say, uh, that agents decides where this query should go next, right? Task query to subtask. Okay, and obviously it divides. There is a planner agent which divides the task in smaller chunks or smaller subtasks, and depends on the subtasks whether it can be executed parallelly or sequentially. That gets decided here. The manager agent receives the main prompt and breaks it down into internal loop. Perfect. And that goes into the loop until we found satisfactory answer. Chain of thoughts. And third one is like stateful graph routing. Frameworks like a graph QL, not GraphQL, sorry. It's a lang graph uses a directional graph. So we decide different nodes. So different nodes is nothing but our agent, and the line between line to connect those nodes is edge, and that's decide like where the next query will go, right? So we have already seen one example there, and this is one of the video that is recommended. I'll watch this later on. I still didn't get much time to watch it, but yeah, that's the overall thing. For this video we'll try to implement this lang graph, uses the directional graph. So let's just start it. Okay, lang graph orchestration. Okay, example. Well, let's go through the documents only. AI Dev Codex. What is this? ChatGPT. Okay. Lang graph. Agent orchestration. Yeah, perfect. This one is really important. Start building it. Okay. Companies. How does the lang graph help? Guide, moderate, control your agent with a human in the loop. Perfect. Add a human in the loop. That's fine. Build a comprehensive agent workflows. Perfect. See the different agent architecture. Yeah. Different agent architecture. We don't want this. Let's see. Persistent memory, first class streaming, better user experience. Okay, I think this is the one that we want. This one, parallelization. Yeah, that's correct. Evaluate. optimization and routing. Okay, orchestrator worker. Yeah. This one is really important. So workflows. The this guides reviews common workflows and agent patterns. Workflows have a predetermined code paths and are designed to operate in a certain order. Agents are dynamic and define their own process and tool usage. Okay. Prompt chaining. Yeah. You can see this. LLM is embedded in predefined code paths. Okay. LLM directs control flow through predefined code paths. Okay. Evaluator optimization, orchestration worker, evaluator optimization, routing. Okay. I think this is confusing. Anthropic. Okay. The memory tools, search queries, structural LLM. Okay. Let's try to narrow down because this documentation is like a huge. Um, it's really huge. So, what we want? I want to let's say, or else I'll just put it here. I don't want any interruption in between, so I'll just use incognito. Um, so what I want to create. I want to introduce. I want to implement multi-agent architecture using LangGraph. Yeah, multi-agent architecture using LangGraph. Okay. Supervised worker patterns, hierarchical, swarm pattern, decentralized or handoff. All agents are interacted with the user and are freely transferred conversations or tasks directly to another. Mhm, without central management. Supervised worker pattern. One agent, the supervisor, acts as a manager. Yeah, for now we will go with this. We want one agent to decide where it wants to direct this query to. So for our use case, it looks like swarm pattern is helpful. And from this information, it seems like supervisor agent might consume a lot of tokens. Reason being, it should have one manager token, and that is nothing but our LLM only. Or it could be your hard-coded tool, but that doesn't make any sense, right? Um, maybe we'll go with a swarm pattern. What do you think? Interact with the user and freely transfer conversations tasks directly to one another without central management. This is achieved by giving each agent specialized transfer tools. Okay. Okay. What is swarm patterns? Let's try to understand this first. What is swarm pattern? It decentralized multi-agent architecture where agent directly hands off. Okay, understood this. So every agent is specialized in specific task only, and that agent itself has a capacity or capability to transfer the query to the next agent. So that eliminates the need of your manager node and this is how the swarm works. Okay, if user asks to change their shopping address and get the refund previous order, the try agent detects the shipment first. It calls the transfer to shipping. The shipping agent activates, updates the address, and realize a refund is still needed. Also, transfer agent defines the process and confirmation. When the your swarm versus supervisor, user swarm if your workflow is conversational, fluid, and follows a clear departmental logic like travel booking, customer service. Yeah, for us, like it's not a travel booking, but for us it is a hotel booking. So this swarm might be useful. All right, so let's get started. I have hotels booking, um, let's say business. I want to implement it here, right? So keep all. All right, something is not synced. I'll just sync it. Yeah, to implement a swarm multi-agent, your hotel booking will build a graph with a tree, specialize agent, route the request and book agent to check the availability and serve the room. Perfect. Yeah. Executive environment setup. Okay. What do you what do you mean by that? Uh, Git push. Git pull origin. Oh yeah, sorry, my bad. Fail to push. Okay, it might be my my token might be invalid. I don't know. I'll figure it out later. Anyways, so here line graph, OpenAI. Okay, let me first activate my virtual environment. So for that, I have dot slash vnv clear agent. No. I need to go back. Dot slash VNV scripts activate, clear it. Okay, and then this is graph. Okay, let's try to understand this first. Define the agent transfer tools. Transfer tools. In a swarm pattern, the handoff occurs because the agent have the access to transfer tools. Then the agent calls the transfer tool. It signals the graph to route the control to different agent. Okay. Hmm. Okay, perfect. Transfer to the policy agent. Booking. Um, Booking agent will check. Okay. 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 Define the node functions. The routing functions checks the very last message in the shared message state. When we have model, add a node, tree hack, run tree hack. Okay. What are the responsibilities? Okay. Ah, okay. Okay. So, okay. Now we have to really think about this. So, here, what I understood is first we need tools. First, we need tools like this. Second, we need different models. Third, we need, second, we need different agents. Third, we need different models. We'll use these models to invoke a specific query attached to it. And then each model will be linked with another model, let's say triage, booking. And how about previous messages context? We can pass it to, okay, yeah. Hmm. Understood. Okay, yeah. I think I understood this. Let's just start it. Perfect. Um, Hotel ID, post ID, login. Perfect. Yeah, this fine is clean. I thanks that I worked yesterday on this. Not yesterday, last time. Okay, last month. Okay, fine. Hotels website, hotels. Okay, let's just understand this. We have hotels website. We will call it. First, we will log in. After that, log in hotel ID, hotel ID. Okay, hotels, log token. Till now, what we were doing is we were getting that, verifying that token. Yeah, this is fine. This is credentials invalid and hotels list. We were calling this function hotels list. This function, okay, this is in utils, util.py hotels function, hotel list. Okay, it is directly giving this as a output, right? Going forward, we don't want this. Okay, let me add new file. Let's say db.py. Let's say local db.py. I want to shift this list of hotels here, and let's say, yeah, hotels list. Then I also want, let's say, dummy users db. Okay, fine. Do I need this? Yeah, we need this. Then I think we need also like booking dates available. Let's say booking list. Yeah, hotel list. Okay, perfect. So hotel. Okay, let me bring it at the top. I Okay, here. Okay, so now hotel 1 is booked for this and this date. We need to find date difference here. But anyways, any date that falls under this specific date should not be available. Okay, so utils here, hotels list. Um, okay, get hotels. Perfect, fine. Now what I want is I want to search hotels. I want to give an option to search the hotels, but for that I need like a session register, get sessions. What is this? Create session, list session. Yeah, that is for storage, right? Email approval pending, email approval pending. Yeah, uh, login. Perfect. Yeah, I want. Okay. Let's say user logged in. After logged in, create session for the user. That's perfect. And registered it. Chat. We have this chat API which gets called. TP session ID, user message, combined message. Now here we'll have to use this graph. Just like this, if we pass user message, event register, event streamer. Okay. Okay, fine. I think obviously we need local DB. Then for this main function, and if auth token, then we have util. Util is empty. So let's remove this. DB skill schema user operations. Yeah, that's fine. I just forgot where I've created. Okay, inside the APIs. Oh no. Okay. Now I understood this picture completely. For now, I don't use this API, I guess, as far as I know. I am directly going to this chat API, which I just showed you, this chat. And this chat API is creating session. It is fetching previous chat's history, and then it is providing output, streaming an output. That's it. Okay, full. Ah, now, auth utils. Let's see what we have here. Event generator. Fine. I will create a local DB. Local DB dot py, right? And then here I want like a hotels list, booking details. Booking list is fine. For now, we'll just will not maintain any users data or anything. For now, let's just see if we can able to find booking details of a specific hotel, or we, if their booking is already done, we should not suggest it. So our ultimate goal is to, if user ask like check the best vegetarian hotel, that will have to, okay, first, okay, this is a list of hotels in specific area, like say area, let's say location Delhi. Fine. Here also I will keep the location Mumbai. Then let's add two more hotels here. Uh, Hotel 3, let's say Delhi only, right? Delhi only. Perfect. So we have list of hotels. Then we have booking list. So booking list is here, and then hotel specialty, or let's say specialty, I'll add here. Specialty, say pure vegetarian. Specialty is vegetarian. Specialty is, let's say, non-vegetarian. The specialty here is, let's say, non-vegetarian. Okay. Yeah, we have list. We have booking details. And now under this, we'll create some functions so that can help us to grab those information and do the basic stuff here. Okay, so under the utils, probably I will just fetch, let's say, I want to um, mhm, okay, here, if I query something, that should go to uh, this, node value stream inputs, chunk message content pair, graph stream. This is another path. What I'll do is I'll just delete this main and copy main. I'll keep it copied so that I'll not lose my existing functionality, because this is gonna be a huge change for me. Okay, let's just create tools first. Okay, so I will copy this. No, let me write down a functionality so it will be easy. I want to create flow where user can check hotel availability. User can search hotel and check hotel availability, and can sort hotels based on veg, non-veg. Yeah, we have hotels DB. Type is veg, non-veg. Yeah, I think this hotels DB is perfect. Mock the hotels database. Yeah. Hotels DB, local DB, hotels DB, right? Rooms availability. Yeah, that's perfect. Then what about bookings? Rooms available. Yeah, that's also fine. That if we don't provide a date, still we have number of rooms left, so that still can be done. That's perfect. Under the utils function, I will first like import this, import local DB, right? And oh, wait, uh, do I need to define tools mandatorily in here, or can I just segregate those somewhere else? Tool, event tool is here, send mail. Yeah, this is something important to understand this. Okay. Probably this should work because I'm ultimately importing it, right? Ultimately, I'm importing that file, tools file. Okay, let's add tools dot py dot py, and then I will remove this from utils. I don't need this. And then from tools, I need to first import my local DB, and then I need to define a tool, but this should be from, I guess this tool is from which package. So LangChain core tools from, okay, core tools tool, and then get hotels location string. But yeah, that's correct. Hotels DB, do some operations, brother. Hotels DB. Okay, in fact, for hotels in hotels DB, location is uh, if location found, then I just want the hotel. Okay, that's perfect. Then we need a booking check, room availability. Check availability. Hotel ID should be passed. Book a hotel, it's fine. Hotel not found. Hotel ID is not in the hotels DB. Hotel ID, okay, fine. Hotel not found. Okay. Do I have availability column? Perfect. We have these tools. Now we need an agents. Let's say searching agent. Hotel searching agent. Hotel searching agent. Create an agent. Get hotels. Yeah. Not in booking. Searching. Hotel searching. Then we need hotel right, and then I think this two is fine. Binding tool is already done. Run. Yeah, we have this run method. Then associate agent to compile. define swarm router. Something like this. Let's say define swarm router. Okay. Okay. Tools, track, booking, policy, tools, last message. Either booking, if it is coming from booking, then should go to booking, policy to policy, empty or policy. Perfect. Okay. Builder is equal to state graph, matches state, add a node, booking agent, track agent. Do we have this? No, we don't have it. Build swarm. So here, if you see, we have added these nodes. These are nothing but our agents. Tool node, transfer booking agent, tools. Get this tools. Okay. Oh, this is for swarm. Tools. Okay, make an search the hotels, check rooms availability. Okay, your hotel booking assistant confirm the details, use booking. Okay, and make agent mode. Your hotel policy assistant answer the questions about the cancellation and refund policy. Okay, fine. And then we have triac booking. These are the nodes. Start is triac. Okay, add a nodes. Do we have start node here? Where is it? We don't. Yeah, but it's fine. We'll compile. Then we have swarm. Perfect. Now, how to use this swarm? How to use this swarm and chats. Mhm. Minimal event generator for the swarm. Okay. Example flow is input swarm message. Okay, fine. We'll see this later. I got to go now. Okay, thank you.